le bien qu'on m'a fait, ni le mal, tout ça m'est bien égal.
The City of Lights was getting ready to host one of the most important conferences ever held in the history of mathematics. They came from all Europe, England, Germany, and Switzerland. The famous mathematician X was preparing his speech that he would deliver at the conference, and after several days at the conference, he brought his speech to a conclusion by saying that
mathematics is absolute truth. Sooner or later, it will demonstrate whether or not a theory is correct or incorrect, or whether a proposition is true or false. In mathematics, there are no dead ends. We must know, and we will know.
Je repars à zéro. Non, rien de rien. Non, je ne regrette rien. Ni le bien qu'on m'a fait, ni le mal, tout ça m'est bien égal. Ma vie, car mes joies, aujourd'hui, ça commence avec toi.
Kurt, I'm very glad to see you.
Inspector, how are you? They told me it was urgent.
Indeed. Did you know Professor X?
Of course. He's a first-rate mathematician.
X has been murdered.
Oh my God. That's a major blow to science. But when did it happen? Just yesterday afternoon I ran into him, and we had a little chat.
The murder took place late last night. Did you know him personally?
We corresponded regularly about scientific matters.
My condolences for your loss.
Well, what can I do for you?
Well, the suspects are all mathematicians, and you know most of them well. Furthermore, their statements are in the language of mathematics. But I don't suppose that would be a problem for you.
I doubt it.
Great. I think we can begin.
Inspectors Gerard and Kurt examined the statements of 9 mathematicians, but none of them were found guilty.
Inspector, we have another suspect by the name of Phidias. A short time before the crime took place, a member of the hotel staff overheard a conversation where Phidias said, "Do as I say and you will be rewarded with gold."
Aha! Someone who pays in gold for services rendered. Do you know where this Phidias lives? Thank you. Let's go, Kurt.
You know, it doesn't make sense why someone would want to kill Professor X.
I know.
He was just a mathematician, teaching. He didn't do anything wrong. It's not fair. He didn't deserve to die.
He was too great to die. Oh, I think we're here, his studio. But where is he? Okay.
We'll wait for him.
You know, doesn't make sense, Kurt.
His work is very nice.
Oh, really? Yes. Oh, there he is. Excuse
Hello.
me, sir. Are you Phidias?
Yes.
Can I ask you something, sir?
Yes, of course.
Phidias, weren't you at the bar at the Hotel Sorbonne last Wednesday evening?
Wednesday evening. Oh, yes, I was there.
A member of the hotel staff overheard you saying to a person you were with, "Do as I say, and you will be rewarded with gold." What were you asking him to do, and did you promise a reward?
Well, do you know number 5?
Number 5? That's Greek to me.
Exactly. It's a Greek letter that stands for the number square root of 5 plus 1 divided by 2, or approximately 1.618. It's a number with a name like pi. You must have heard of it.
I remembered from school.
Well, the number 5 then, which is also called the golden ratio, whenever it is found in a work of art or architecture, gives a feeling of harmony and beauty.
That is?
Well, do you recognize this?
I think it's Parthenonas.
Yes. Well, can you see the rectangle that forms the front of the building?
Well then,
It's golden.
come on now. All the world knows that it's made of marble.
No, we call the rectangle golden because the ratio of the two sides approximates the number 5. For example, a rectangle with sides of 89 and 55 is golden, since 89 divided by 55 approximates 1.618. Do you recognize this theater?
I think it's the ancient theater of Epidavros.
It is indeed. Does it seem beautiful to you?
The ancient Greeks knew how to create beautiful things.
So the theater wasn't made this way by accident.
Such masterpieces are not left to chance.
Well then, take a look at the two sections of the seats.
Well then,
The first section has 34 rows, and the second one has 31. So the total is 55. And I think that 34 divided by 21 approximate 1.619. And 55 divided by 34 approximates 1.618. Leonardo da Vinci made his paintings with golden proportions, and the values of Stradivarius, which are the best in the world, were made.
Phidias, you need not go on. You've persuaded me that phi is a golden number that is connected with aesthetic perfection. Everything you've said has been very interesting, but I must inform you that you're a suspect in the murder of Professor X, and you have to give an account of yourself.
Well, do you see this 5-pointed star? It was the sign of the school of Pythagoras.
More of the same, Phidias, I'm warning you.
Well, just give me a minute and I will give you a statement. Well, each of the 5 triangles, it's an isosceles triangle with 2 angles of 72 degrees and one of 36. And the equal sides have the length of 1 unit. What I said to my companion was, find the length x of the unknown third side, calculate the ratio 1 over x, and you will be rewarded with gold. Anything else you want to know, sir?
Yes, actually, would you mind if we use your studio for just a moment?
Of course, it's okay.
Thank you.
You're welcome.
Thank you. Let's see. We need to calculate 1 over x. First, we draw a line segment BD, which bisects angle B. Now we have AB equals BD equals BC, because both of these triangles are isosceles. Also, CD equals 1 minus x. The triangles ABC and BDC are similar. The proportions which follow from this similarity are 1 over x equals 1 over x equals x over 1 minus x. If we do the following equation, we will be able to calculate 1 over x, which is square root of 5 plus 1 divided by 2, which is the number phi. Do you see now what Phidias meant when he said, do as I say and you will be rewarded with gold?
I do. But, Kurt, did we have to draw BD?
Could we find what we're looking for in any other way?
From the trigonometric tables, we could find the sine of 36 degrees and calculate the side BC using the sine rule. Or we could find the cosine of 36 and 72 degrees and apply the sine rule.
Inspector, I'm impressed.
So, Phidias is innocent. So there aren't any suspects left. Oh my God. It seems that mathematics doesn't solve all problems.
What?
I said mathematics doesn't have all the answers.
That's it. I know the killer. To be precise, he's standing in front of you right now, speaking to you at this very moment.
You mean you...
Unfortunately, Inspector.
In the name of God, Kurt, speak to us. I'm going out of my mind.
At the conclusion of X's speech at the conference, he'd asked me if I had made any progress with my paper. I told him I had finished it, and he asked if he could have it so he could study it. I'll do my best to describe the content of the paper, simplifying a few matters for ease of understanding. Let's consider the set of all prime numbers, including 1. We have the set A of 2, 3, 5, 7, 11, and 13. With a little multiplication, we can create any positive integer. If, however, we limit this set of prime numbers, let's take a subset of our set A, the set B, of 2, 3, 5, and 7, we cannot produce the same result. We can create the number 10 as it results from the multiplication of 2 and 5. We can create the number 4,200 as it results from the multiplication of 2 to the third power times 3 times 5 to the second power times 7. The number 26, however, cannot be created as it results from the multiplication of 2 and 13, and 13 is not included in our subset B. I suppose furthermore that you remember from school that in order for a mathematical theory to be adopted, we have to accept certain propositions without proof. We call these propositions axioms, and we use these axioms to prove other mathematical statements or theorems. Naturally, we have to limit the number of axioms we use. So let me now make an example from here. So just as out of a limited number of prime numbers, we can construct an infinite amount of positive integers. So out of a limited number, but not all. So out of a limited number of axioms, we can prove an infinite amount of statements, but not all.
And so?
What I have proven is that mathematics may not be a perfect science as we may have thought, since there will always be statements or conjectures in which the truth and falsehood cannot be determined.
And what does all this have to do with the crime, Kurt?
The proof of my theorem was the last thing that the professor read. My notes were found on the table next to his lifeless body. The phrase with which he finished his speech, "We must know and we will know," was still ringing in his ears as he read the proof of my theorem. That night, reading the proof of the incompleteness of mathematics, the professor felt betrayed. He had dedicated his life to the study for truth, and when it was revealed to him, it took his life. The truth killed Professor X.